to make a brief introduction into how you can perform mesh analysis. So for this purpose, I have prepared the following exercise. We have the following circuit. And remember that to apply mesh analysis, we need to identify the, um, the loops of the circuit. So for example, here we have a loop where the current I1 is flowing. We have a loop with the 8 ohm resistor, the impedance of the inductor, and the capacitor that is in this side, in this part. Okay, we have this inductor, this capacitor, and this inductor right here, and also we have this resistance. Also, we have another loop in which we have this capacitor, this other capacitor, and this resistance of 4 ohms, and also we have this voltage source. And also we have another loop in which we have the current source, we have this capacitor and this inductor. Okay, so for mesh number 1, we can apply the Kirchhoff voltage law to this loop. Okay, so for example, and we need to add the voltages that that are applied to each of the components in this loop. So for example, the voltage of the 8 ohm resistor can be computed as follows. First, I will assume that the voltage drop in the 8 ohm resistor is equal to 8. It is a positive voltage drop, okay? And we have here 8 ohms times the current that is flowing through the 8 ohm resistor, that is I1, okay? Plus, okay, the voltage drop that is applied to the inductor with an impedance of J times 10 ohms. Okay, and well, this is equal to the current that is flowing through this inductor. But the current that is flowing through this inductor is equal to the difference in currents between mesh number 1 and mesh number 3. And the current that is flowing in mesh number 3 is I3. So the current that is flowing through this element is the difference between I1 minus I3 times the impedance, that in this case is J, 10 ohms. Plus, we have another voltage drop in the capacitor that is in this part, okay? So the voltage drop in this capacitor is equal to the difference in currents between mesh number 1 and mesh number 2 times the impedance. So the current that is flowing through this element is the difference in currents between mesh number 1 and mesh number 2. So it's I1 minus I2 times minus J2 ohms, and this is equal to 0. And well, this is for mesh number 1. For mesh number 2, we have the following. We have for mesh number 2, well, we can apply the voltage, the Kirchhoff voltage law in that loop. So we need to first compute the voltage drop in this capacitor. So the voltage drop in that capacitor is the difference in currents between mesh number 2 and mesh number 1 times the impedance of the element, that is minus J 2 ohms, plus the voltage drop in the other inductor at the top. And the current that is flowing through this capacitor is equal to the difference in currents between mesh number 2 and mesh number 3. Okay, times impedance, that is minus J 2 ohms, plus the voltage drop of the 4 ohm resistor, that is I2 multiplied by 4 ohms, plus the voltage of the voltage source. But in this case, you can see that I2 is flowing through in this direction and is entering through the positive terminal of this voltage source. So we say that I2, well, that here I2 is entering the positive terminal, so this voltage is equal to plus 20 with an angle of 90 degrees volts. Okay, so let me erase this to be a little bit more clear. Okay, and this should be equal to 0. Okay, so this is the for mesh number 2, but you can observe that we have one problem here. Is the fact that we have two equations and we have three incognitas. We have I1, I3, and I2. Okay, so we are missing one of the equations, but hopefully we know that I3 is equal to the current of the current source that is in this part. Okay, so since the current I3 is pointing to the same direction of to this current source, we can say that I3 is equal to 5, okay, with an angle of 0 degrees amperes. Okay, and mm, I think that well, we have all the currents, so we can introduce this system of equations in which we have three three equations with three incognitas, no? The incognitas I1 and I2. Also, we know I3. In fact, you can substitute the value of I3 into these two equations. Okay. So, the result of I1, if you input all these equations in your calculator, will be equal to 3.59016 with an angle of 55.0079 degrees, and these are amperes. And I2 is equal to 6.1209 with an angle of minus 35.2175 degrees, and these are amperes. Okay, but I forget to mention something important. According to the original problem, we needed to compute the current source that is labeled as I sub 0. That is this current that is flowing from the negative to the positive terminal of the of this voltage source. Okay? So, but we can also see that this current is equal to the current I2. So we can say that I sub 0 is equal to I2, but since these two currents are pointing in a different directions, we need to place a negative sign in order to indicate that I sub 0 is equal to the negative of the current I2. So if we substitute this value of I2 in this equation, we will see that I sub 0 is equal to 6.12019 with an angle of 144.7824 degrees, and these are amperes. And this is the result. Okay, so that's all for this video. Thank you for watching.